Imagine a chain that is so strong that it can keep huge boats in place during the worst storms. But how do they get to be so assertive? It needs fire, power, and an industry that has been making things for over 60 years. From heated steel to a noisy hammer, this is not a regular process. Are you interested in what was used to create these strong bands? Stay with us. The journey for the scenes will really blow your mind. Firstly, manufacturing a warship anchor chain begins with material selection. Due to its toughness and seawater resistance, high-strength steel is used. Ship size and weather determine steel type. Some chains anchor large ships, while others handle storms. However, nickel, chromium, and molybdenum strengthen steel. Metals make steel more challenging and wear-resistant. Furthermore, after selecting the proper steel, long bars are formed. Strong, consistent bars are needed to make a chain that can withstand heavy loads. Advanced machinery heats and rolls steel into thick, even bars suitable for the next step in factories. Here's what comes next. After the steel bars are ready, they must be cut into smaller pieces to form individual chain links. This cutting process is precise and must be done carefully. The steel bars are measured and marked before being cut to ensure that every piece is the exact size needed. Moreover, large cutting machines slice through the steel with incredible force, making sure each section is just right. If the pieces are too short or long, they won't fit together properly. In addition, advanced computer-controlled machines help make sure every cut is accurate. Once all the pieces are cut, they are inspected to make sure there are no cracks or defects. Even the smallest mistake in cutting could weaken the chain. After cutting, the steel pieces are moved to the next stage, where they will be shaped and prepared for heating. Let's keep this moving. Heating the steel is super important. The cut pieces go into these huge furnaces that get super hot. The heat really softens and moves the steel, which is super important for shaping those links just right. However, if the steel isn't heated just right, it can end up cracking or breaking when pressure is applied. We really need to keep an eye on the temperature. If the heat is too much, the steel can get weak. But if you don't heat it enough, it becomes really tough to work with. But wait, there's more to see. When the steel becomes red hot, it gets quickly taken out of the furnace and moved over to the forging area. Timing really matters. If the steel cools down too much before we start forging, it's going to be tough to bend it into the right shape. Workers need to move quickly to keep the steel at just the right temperature for shaping. And that's just the beginning. Forging is where the steel pieces turn into actual chain links. While the steel is still hot, massive machines press and bend it into the shape of an oval link. The ends of each piece are joined together using high pressure. This ensures that the links are strong and will not break when welded. In fact, some factories use hammer forging, where giant mechanical hammers repeatedly hit the steel until it takes the right shape. Others use hydraulic presses that squeeze the steel into place with thousands of pounds of force. Either way, the steel is shaped carefully to ensure each link is uniform. After forging, the links are cooled slightly before they move on to the next stage. Once the links are forged, they must be welded together to form a continuous chain. This is one of the most important steps in the process. The ends of each link are heated again and fused using special welding techniques. By the way, arc welding and submerged arc welding are common methods used. The welding process ensures that the links do not have any weak points. Furthermore, each weld must be inspected carefully to ensure no cracks or gaps. Strong, flawless welding keeps the chain from breaking under heavy loads. After welding, the chain is checked again. If a weld is not perfect, the link must be redone. Stud insertion is the next step. Some anchor chains, especially those used for warships, have studs in the middle of each link. These studs add extra strength and prevent the chain from twisting. Even the studs are made of the same high-strength steel as the chain and must be fitted perfectly inside the links. Machines place each stud in the link center before it is fastened. To prevent movement, the studs are bonded inside the link. Each stud must be perfectly centered for this process. Incorrectly placed studs might weaken the chain. After inserting and welding the studs, the chain is tested again for alignment. Moreover, heat treatment strengthens chains. Huge burners heat the linkage to incredible temperatures. It cools quickly in oil or water. Quenching strengthens steel. The chain heats once more at lower temperatures after cooling. Tempering, the second heating phase strengthens and stretches. Under pressure, 2 hard chains break and 2 soft chains bend. The heat treatment gives each link the correct stiffness and strength. The steel chain is inspected after completion to verify seawater resistance. It only gets more exciting from here. Surface treatment comes next. This step helps protect the anchor chain from rust and corrosion. Since the chain will be underwater for long periods, it needs a protective coating to keep it from wearing down too quickly. However, galvanizing, dipping the chain in molten zinc, is used regularly. Zinc coating guards against rust. Shot blasting cleans and strengthens the chain by blasting microscopic metal particles. Furthermore, some chains are coated with marine-grade paint to resist seawater corrosion. These treatments keep the anchor chain working for years. Thus, this is all about organizing everything in the inserting process, in which case we build and test the completed chain. Every link in the chain connects to produce one continuous, intact piece. The chain anchor is almost there. A few further adjustments will help it to be robust and long-lasting. Now it starts with grinding. Powerful machines smooth out any rough edges on the chain links. Every little bump or sharp corner is carefully removed so the chain is perfectly shaped and safe to handle. So, the chain then passes undershot blasting. Imagine small steel balls polishing the metal surface at great speed. This removes corrosion, dirt, or flaws, preparing the chain for coating. Now it's time for the protective coating. The chain takes a dip in a huge paint bath. This isn't just any paint. It's a special waterborne asphalt coating. The bath is 10 meters deep and the chain is fully submerged to cover every inch. And the coated paint is done. After the paint dries, surface detection machines check every link for quality. Finally, Kent and arc shackles are tested to ensure everything is strong and ready for action. They undergo strict quality testing before these powerful anchor chains can set sail. Experts check every link with advanced machines. Tensile tests pull the chains incredibly to ensure they won't snap under pressure. These chains must pass difficult tests before they leave the plant. Experts from Japan's NK, the Norwegian Classification Society, and the DNV closely examine every aspect. Lloyd's Register offers a certificate of approval as well. In addition, certified only are the chains that satisfy strict criteria. This guarantees they satisfy the highest ship-related international safety criteria. The anchor chains are finally ready after passing all the tough tests. There's one final check though. There is one last check by a professional to ensure that every anchor chain is strong and perfect. After being accepted, the real work starts. These heavy chains are loaded onto ships by huge cranes that work very precisely to lift them. The port doesn't wait for anyone. so time is very important. Building battleship anchor chains is an exciting experience, starting with raw steel and ending with powerful, sea-ready monsters. Every bond tells a tale of power, accuracy, and faith. Stay tuned for more amazing stories. Thank you for watching.